Let's continue our exploration of the angle criteria in various geometries and see if that's enough to make two triangles congruent. We found it was enough for hyperbolic, but not Euclidean. Let's take a look at spherical. Here we go. Now, like hyperbolic, this is going to be a little difficult to make this one work out well. So it's not as clear of an illustration as what we've seen before, but we have three angles that we can specify. Now, if they're too small, if the sum of the three angles is less than pi or equal to pi, then no such triangle is going to be possible. We know that about spherical geometry already. But if the angles are sum up to more than pi, then we will get a triangle. Let's see what happens. So we start with one angle here. We can move that around, and it's controlled by this slider, this number. Now we pick a point here, and we can control that angle by this slider and that number, and it can be moved around this ray, including, way over here. Okay, now on the other hand, we have another point on the other ray, and we have an angle there. The problem is this blue one needs to go through this point, and this green one needs to go through that point. So it's easy to fix one of those things or the other, but it's not so easy to fix them both. See, it doesn't. See, it's like the hyperbolic case. It's going to take me a while to get even close to getting these to match up. It's like, oh, we're getting close. I probably can't get it exactly, but that's pretty close. Not quite there, but we're pretty close. But can you see that it's likely that there's only one possibility here? We're close to it right there. Okay, so it turns out that like hyperbolic geometry, the angle situation is enough to give us triangles that are congruent. So, given three angle measurements, if the measurements add up to pi or less, then there's no congruence classes possible, no triangles possible, zero congruence classes. And if the three angle measures add up to greater than pi, then there will be exactly one congruence class. If you have two triangles that have the AAA, all corresponding angles are congruent, then in fact all the corresponding sides must be congruent, and well, the triangles are congruent. This is in spherical geometry. We got a different result in Euclidean geometry. In Euclidean geometry, angle or angle was not enough to make the two triangles congruent, but it was enough to make them triangles similar. Here we see that like in hyperbolic geometry, there are no similar non-congruent triangles in spherical geometry. So AAA works for spherical.